have a relationship between x and y, an input and an output, if that thing is really a function or not. So what is the actual definition of a function? Well, a function is any kind of relationship between two variables, say like x and y, where we think of the x being the input and the y as being the output, and the only rule is that each input has just one output for each value. So let's take a look at this little table here. So here I'm thinking about the x's as inputs and the y's as the outputs, and the question is, well, does this chart represent a function? Well, the question is, does each input have only one unique value as an output? Well, let's take a look. 0 is hooked up with 11, and there's no other zeros on my chart hooked up with any other number. So each input has one output. 2 is hooked up with 10. Are there any other 2's on my chart? No, so I'm fine. What about 4? 4 is hooked up with 9, and there are no other 4's on my chart, so therefore that's good. 6 is hooked up with 8. There's no other 6's. So there's no value for an input that results in two separate different outputs. Each input has only one output. It's a function. Let's take a look at another example. This one is a geometric one. Well, here I'm looking at this circle, and I'm asking, does this circle represent the graph of a function? Well, that's asking us, is it the case that for every input, for each x, there's only one output? There's only one y. Well, let's take a look and check it out. For example, let's take a look at the point x equals negative 5. That's right here. When x equals negative 5, what's the output? Well, you sort of shoot up and you see, oh, look, the output's right here because there's the circle. You can see it's at 2. But wait a minute, if I keep going up, I see the output again, 4. So if we were to consider a table, we'd see that we'd have negative 5, comma 2, but we'd also have negative 5, comma 4. That is, we'd see that negative 5, for that particular input, we'd have two different outputs, 2 and 4. This is an example of a relation that's not a function. Now, how can you see this visually? Well, visually, the way you can see that for this particular x value, there are two y values, you'd notice that if I put down a vertical line, the graph actually cuts the vertical line in two places. This is often referred to as the vertical line test. The vertical line test means, can you actually draw in vertical lines, and if you ever see the vertical line crossing your graph at more than one point, then that graph does not represent a function. It can't, because for a particular x value, you have two outputs. So in this case, we see that by the vertical line test, this circle is not a graph of a function. Not a graph of a function. Cool. All right, let's take a look at one last example together. I know you want to see more, but I'm cutting you off here. So here's an equation, y equals x squared plus 1, and I want to see if this thing is a function or not. So what I'm going to do is I'm going to try to graph this thing by producing a little table of values, inputs and outputs, and then try to look at the picture and see if it passes the vertical line test. Okay, so what am I going to do? Well, I will pick some sort of standard looking points. I'm going to pick negative 2, negative 1, 0, 1, 2. Those are my favorite points if I have to pick some. And so for each of these, what I'm going to do now is I'm going to take that value for x as the input, put it into this little machine, and that's going to spit out the value of y. So y will equal the result of this side with x taking on a particular value. For example, when x takes on the value negative 2, put a negative 2 in here. Negative 2 squared is 4. 4 plus 1 is 5. So the output is 5. Y equals 5. What about when I plug in negative 1 for x? That's negative 1 squared, which is 1. 1 plus 1 is 2. What about when x is 0? That's 0 squared, which is just 0. Plus 1 is 1. Plug in 1 here. 1 squared is 1. 1 plus 1 is 2. So the output is 2. And finally, on my little chart, if I plug in a 2 for x, that's going to be 2 squared, which is 4, plus 1 produces an output of 5. So now I've got a table of x and y values, and I can actually now look at the graph. And let's see if it's a function or not. So I have negative 2, comma 5. So that's negative 2 in the x direction. Remember, it always comes x first. 5, jump way up here. 4, and 1 more is 5. Negative 1 in the x, that's 1 unit over to the left. 2 up for y. At x equals 0, y equals 1. When x equals 1, y is 2. And when x equals 2, y is 5. Now notice that's not going to be a straight line. If we connect them, we actually get a very pretty and very symmetric object. It's actually an example of what's called a parabola. We'll see them a lot. Let's just draw it in. Look how beautiful, by the way. That is so pretty. So it's a very symmetric looking thing. So it comes down, turns, and goes back up. The question is it a function? Well, that really boils down to, does it pass the vertical line test? Every time I draw a vertical line, does the curve cut the vertical line at most 1 point? Well, look, every time I put down a vertical line, it only touches at 1 point. So in fact, this is an example of a function. You can also see that by looking at the chart. Notice that for each x value, each input, there's only one output. Now, some people might be fooled by this and say, hey, wait a second. Look, there's a similarity here. These are both values of 2. That's completely okay. It's okay to have two different inputs resulting in the same output. That's fine. But we just can't have one input resulting into two different outputs. And notice that for here, I only have a negative 2 appearing once on my chart, negative 1, 0, 1, and 2, and I don't have any other 2, x equals 2, associated to a different value except 5. And that visually is seen by looking at these vertical lines and seeing that I only cross this curve at most 1 point. It never loops back onto itself. And so therefore, this is an example of a function. Anyway, functions are very, very important. In fact, they're not only within math, but they're all around us. In fact, the whole world is just a bunch of functions put together. Anyway, enjoy thinking about functions, enjoy thinking about the vertical line test, and I'll see you soon. A function is a really special type of relation. It's a relation where the first coordinate never is repeated. So here's some data. This is a table. It's the federal minimum wage for covered non-exempt employees. It's basically just the minimum wage over the years. So you see 1970, 1975, 1980, and so forth. If we wanted to, we could actually produce ordered pairs for this data, understanding that this year is going to represent the x and the actual wage is going to represent the y. So just to illustrate, let me just write down a couple of them. So the first ordered pair would be 1970, comma, $1.45. That represents the first ordered pair. And this would be the second ordered pair, 1975, comma, $2, and so forth down the line. So we'd have all those ordered pairs. So to see if this relation actually represents a function, all I've got to do is ask, do we have the first coordinate appearing more than once? And if we look, we see that the first coordinates never repeat. 1970, 75, 1980, 1985, 1990, 95, 2000, never repeat. So since the first coordinate never repeats, that means this relationship is a function. Again, if we never see a repeat in the first coordinate, that means we actually have a function. So this is an example of a function.
Okay, if you haven't done so, for example 2, be sure to get this definition down. A function is a relation in which there is only one output for each input.
You know, if we look at a graph, we can actually determine if that relationship is a function or not. Remember that the only test is to see if, in fact, the x value only appears once. So let's check this out. So here's a picture. Well, one way to see if the x value only appears once is to use what's called the vertical line test. Put down vertical lines anywhere and see if it ever crosses the function at more than 1 point. Well, here you can see, my gosh, it crosses the function at a lot of points right here. It crosses here and here. That means for this one x value, there's two possible y values. That immediately means this is not a function. This is merely a relation. It fails the vertical line test. to pass the vertical line test, you only pass through the vertical line once for each and every point. How about this? Well, in this region, it looks pretty good. Notice the vertical line only crosses this curve at one place, so it's looking like maybe this is going to be a function. Oh, but then I get in trouble here because the vertical lines here, notice, cross the curve at 3 points. That's more than once, so that means that for this x value, there are 3 possible y values. This is not a function, it's merely a relation. What about this more complicated graph? This is a really crazy graph, and notice there's actually a break in it. Well, if we try the vertical line test, notice it looks really, really good all here. Only crossing at 1 point, only crossing at 1 point, only crossing at 1 point, only crossing at 1 point. But what about right here? Oh, notice that these dots are colored in both places. And so, in fact, we see this fails the vertical line test at 1 point. But that's all that's required in order for this not to be considered a function. This is just a relation. Finally, what about this? Well, notice as I journey through with my vertical line, it only passes the curve at 1 point. This, in fact, is a function. This, in fact, is a function. Could you imagine seeing a function or a relationship that's something that is not a function? How would you imagine seeing that if you were looking at a chart? If you were looking at a chart, you could imagine the following chart. Let's consider for the x values people's social security numbers, and let's consider for the y values their telephone numbers. Well, would that relationship be a function? Well, in that chart, we'd actually see the answer is no. And why? Because with that particular table, if you think about me, for example, I have a social security number, but I have 3 different phone numbers. I have a home telephone number, a cell telephone number, and an office telephone number. So you would see my social security number for an x value, comma, my home telephone number, and then later on you'd see my social security number again with my cell telephone number, a different number, and then finally you'd see my social security number again, comma, my office telephone number. So you would actually have 3 points, 3 ordered pairs with the same x value, but they would be associated with different y values, representing my different 3 phone numbers. So there's an example where you'd see in a table that you would not have a function, you would merely have a relation. So whether you're looking at a table or looking at the vertical line test on a picture, we can determine whether we're looking at a function or just merely a relationship between x and y. Anyway, enjoy these functions, and I hope that you feel that they're your relations. I'll see you soon.
All right, all he's saying is if you wrote it out in a table or as an ordered pair, the social security numbers would be your x, and the telephone numbers would be your y. And notice how the x is repeating. The social security number is repeating. Now, because it's repeating, this makes it not a function. It makes it not a function. Okay, but now notice what happens if we were to switch our values around. That is, we made the telephone numbers the x values, and we make the social security numbers the y values. So now x does not repeat, but y does. And if you notice, this relation is a function because y can repeat, x cannot. Y can repeat, x cannot. All right, so that concludes our lesson for examples 1, 2, and 3 on lesson 6.1. All right, so let's go ahead and get to work.